Advanced dimension options start with the degenerate dimension. These are columns in the fact table that do not qualify for a separate dimension table and are not related to other dimensions. The parent-child property comes from a self-referencing relationship in a single dimension table. Here, we're able to have a balanced or ragged hierarchy. The role-playing dimension provides a method to use the same dimension while relating to different surrogate keys and values in the fact table. This relieves the management of the same dimension table as multiple dimensions. The degenerate dimension. A request to use a degenerate dimension comes from a user that wants to slice or dice by a fact column. In our example, the customer PO number and carrier tracking number have been requested as filters. Be aware, these requested columns increase the size of the fact table, but it does not warrant a new dimension table to be created in the database. The values from the fact table do not have related dimension attributes, so the large range of values do not require a separate dimension. To create a degenerate dimension, there are a couple steps needed. First, we need to create a dimension from the fact table with the dimension wizard. The primary key of the fact table is used as the key column. The name column can be one of the primary key columns because we will hide this key from being displayed. After the dimension is created, we need to add the new dimension to the cube. The development environment recognizes the primary key from the data source view and creates the fact relationship in the dimension usage for us. This can also be automatically done in the Cube Wizard if you select it. Just remember to modify the dimension after finishing the Cube Wizard with the Dimension Designer. The wizard does not know what columns you want as dimension attributes for the new fact dimension. Using either option, you still have to make invisible the key attribute of the new dimension. Now we'll create a degenerate dimension. We start by opening up SQL Server Data Tools. Either we can do this from our desktop or go to the Start Programs menu to find SQL Server Data Tools. Once it's open, go to the File menu choice, Open, and click Project Solution. Next, we'll go to the folder that we installed the files based on the instructions for this course. We'll go to the Start Chapter 05 folder and open up the solution, AdventureWorks DW 2014. This solution is necessary in order to use this example of degenerate dimension. Once we have the solution open, we're going to right-click on Dimensions and click New Dimension. When the welcome screen comes up, we'll click Next. Use an existing table is the option we will use for the dimension creation, and we will click Next. Next, in the Main Table drop-down, we'll select Fact Internet Sales. The key columns are the keys that are defined in the data source view. Since there are multiple key columns, there is no name column selected. You must select a name column in order to continue. We'll roll down the name column drop-down and we'll get a list of the columns from the Fact Internet Sales table. Here we're going to select Sales Order Number and click Next. We'll deselect all the related tables to this fact table. Those relationships are already created for measure groups. We'll click Next. Now we'll select the columns that we'd like to appear under this dimension. The first one is the key, Sales Order Number, and if we scroll to the bottom of the list, we'll have to unselect the key columns that are surrogate keys to the dimension tables. Since this is a degenerate dimension, we're going to select the carrier tracking number and customer PO number to be our attributes for this dimension. We'll click Next. Here, we'll name the dimension internet sales rather than fact internet sales. We'll click Finish, and before we continue, let's right-click the project and deploy. It's always a good idea when developing a multidimensional cube to constantly deploy after making changes to make sure there are no errors. The last thing we need to do in this dimension designer is highlight sales order number, our key column for this dimension, and go to Properties. Here we want to set the attribute hierarchy visible to false. We don't want to display the sales order number based on the combination of order number and line number. We'll go ahead and deploy the solution again just to make sure there are no errors with that change. And next we'll have to edit the cube to relate this dimension to internet sales. We'll go back to the Solution Explorer and double click the cube. Here we're going to go to the second tab, and before that I'm going to pin down my window so we can see a better view of the design environment. The second tab over when editing a cube in the Cube Designer is Dimension Usage. When we click that, we'll see the relationships between our existing dimensions and the measure groups previously created. Under Reseller, we're going to right-click and add a cube dimension. This is how you're able to add dimensions that were not added during the Cube Wizard. We'll select Internet Sales and click OK. And if you notice, the sales order number key is automatically related to Internet Sales Measure Group. If we click on that ellipse button, we'll get a prompt that says it knows that this is a fact relationship. Because we defined this relationship in our data source view, it knows that the dimension created from the fact table is related by that key sales order number. The dimension table and measure group are the two that are related together in this relationship. We'll click OK, go back to our Solution Explorer, and deploy the cube. While we're deploying the cube, we're just making sure that there are no errors with the changes we just made. Once that deployment is completed successfully, we'll click back in the Cube Designer and go to the Browser button. Here, we're going to drill into the measures under Measure Groups, drill into the folder Internet Sales, and drag our Internet Sales to the work area. Next, we'll scroll down in the list under Measure Groups and find our new dimension, Internet Sales. Here, we can drill in and drag our carrier number to the work area, and now we can see, based on carrier number, how much sales was for that number. We can also drag out PO number and see the combination of carrier number and PO number and the total sales, or remove carrier number and see the totals for just PO number. The parent-child dimension. A parent-child relationship in a dimension table is a self-referencing column. Every employee has a boss except the boss, but the boss is also an employee. The relationship and columns are in the same table. This table must contain a primary key to be the key for the employee and a foreign key to be the parent employee key. The diagram to the right shows the employee key as the primary key and a relationship to the foreign key, which is parent employee key. The hierarchy created in an analysis services dimension can be ragged or balanced. This option serves this tool well in its ability to be flexible for end-user reporting. The dimension usage is defined as a regular dimension. The dimension property has to have the key attribute with the usage property set to key. This is always the case for a dimension created with the Cube Wizard or the Dimension Wizard. The additional requirement is for the parent column to be created as an attribute, and the property usage is set to parent. The Dimension or Cube Wizard will create these attributes and properties based on the definition in the data source view. There are additional properties available to customize this hierarchy. They are naming template and members with data. Now let's create a parent-child relationship. We'll start by opening up SQL Server Data Tools, which is on our desktop. We will select the project from the Start Chapter 05 folder and the solution called AdventureWorks DW 2014. We go to the File menu, Open, Project and Solution, go to Start Chapter 05, and select the solution AdventureWorks DW 2014. Next, we'll go look at the data source view. In the Solution Explorer, we'll double-click Data Source View. Here, we're going to have to add the employee dimension to the data source view. We'll click in the upper left in the diagram organizer on Reseller Sales. Next, we'll right-click in the empty area of the workspace and click Add Remove Tables. Here, we'll select Dim Employee and move it to Include Objects and click OK. We'll see that the dimension employee has that self-referencing relationship between parent employee key and employee key. This is necessary in a dimension to create the parent-child property. We'll click OK. Next, we'll save this data source view and close the current open windows. Next, we need to create the dimension for this employee. But before we do that, we need a name for it. We'll go back to the data source view, right-click in Dim Employee, and create a new name calculation. We're going to call this column Full Name. The description we're going to call Employee Full Name. And in the expression, we're going to build a case statement in order to display the full name. Here, we're checking to see if the middle name is null. If it is, we'll just concatenate first name with last name. Else, we'll add the middle name to this concatenation. And then we have to end this case statement. We'll click OK and right-click the dimension and explore data. Here we'll be able to see what was created in the last column of this display for our full name. We'll close the Explore Dim Employee table and close our data source view and save. Next, we'll create the employee dimension. In the Solution Explorer, we'll right-click Dimension and create a new dimension. We'll click Next on the Welcome screen. We'll use an existing table and click Next. And from the main table list, we'll select Dim Employee. The employee key is our key column, but we need to change the name column to the new named calculation Full Name. Once we have that selected, we'll click Next. We'll uncheck the related tables, click Next, and now we can select the other attributes we want on the employee dimension. We have to keep employee key and parent employee key in order for that to be displayed in the parent-child relationship. Next, we'll select vacation hours and sick leave hours, and if we look towards the bottom, we'll see the surrogate key for sales territory. We'll uncheck that, click Next, and change the name to employee. Once we finish this, we need to go to the Solution Explorer, right-click the project, and deploy. Here we want to make sure there are no errors before we continue. We'll go to the Browser tab of the Dimension Designer for the employee dimension. Here we can see that hierarchy for parent employee key was created and that the employee key is invisible to the display. If we drill in from the All level, we'll see the highest level, Ken, If we drill into Ken, we'll see a level Brian S. Weckler. If we drill into this person, we'll see his name repeated twice under him because his sales get summed up to his total sales as a boss. We could change this behavior by going back to the dimension structure, click on the parent employee key, and go to properties. In the property member with data, we could change the non-leaf data visible to non-leaf data hidden. Once we make that change, go back to Solution Explorer, right-click the project, and deploy. We're deploying again to just check for errors to make sure the change we made is successful, and once it is, we'll go back to the Browser tab. We'll have to reconnect to see the change. It's in the toolbar under Dimension Structure, and once we do that, we'll see that Brian is no longer under himself. The role-playing dimension is a dimension that has its primary key related multiple times to the same fact table, but to different columns in that fact table. In this example, you can see the dim date table is related through the date key to the fact internet sales table, but it has a relationships to 3 different date columns: due date key, ship date key, and order date key. This is located in the data source view and was based on foreign keys. The date dimension is defined once as a dimension in the Analysis Services project, although it could be created multiple times with different names from the same date table. In this example, you see there's no order date dimension or ship date dimension or due date dimension, just one date dimension. This allows you to just modify the date dimension in one place. You do not have to worry about modifying the changes in different dimensions. The process is handled in the dimension usage area of the cube. Here you can see that the date dimension has 3 entries, one for due date, one for ship date, and one to order date, although it's still the same dimension, date. Each type has a different relationship with the measure group Internet Sales and Reseller Sales through a different surrogate key value. In this demonstration, we're going to look at a role-playing dimension. We're going to open up our project in Visual Studio or SQL Server Data Tools, and we're going to open up first the data source view of VentureWorks DW 2014. We'll click on the Internet Sales in the diagram organizer, and we will see that the fact Internet Sales has one relationship to the date dimension. If we double click that relationship, we'll see that order date key is related to date key. We'll click OK, and we'll notice we also have a due date key and a ship date key. Now, if we drag the date key from the dim date over one of those columns in the fact table, we'll get a message. The message says the relationship is currently between a primary key column and a non-primary key column. If this is correct, click reverse. So if you drag and drop the wrong order of columns, it recognizes that and has a button for you to reverse that relationship. Once you reverse it by clicking the reverse button, the message will go away. Now we'll click OK. So this time, instead of dragging the date key to the fact table, we'll drag the surrogate key from the fact table to the surrogate key in the date dimension. And this time we won't get an error message, except it says that we've already had that relationship. So we'll click cancel, and we'll highlight due date this time and drag it to date key. Now we get the relationship without any message. We'll save our data source view by clicking the save button and close the data source view. Next, we have to show that relationship in a cube. We'll double click the VentureWorks DW 2014 cube and go to the Dimension tab. In order to see that tab more clearly, we're going to pin the Solution Explorer as well as the Properties off to our right. Even though those menus are still available to us, they're just pinned to the side. So here in the Dimension Usage tab of the cube, we can right-click under Geography and say Add Cube Dimension. When we click that, it's going to give us a list of the dimensions that are created. We'll highlight Date and click OK. And the cube actually recognizes that there are multiple relationships, and it even gives them names, ship date and due date, because if we click the ellipse next to the relationship between the Internet Sales Measure Group and the date dimension for ship date, we will see that it recognized the ship date as being the surrogate key because that is defined in our data source view. So the data source view is the most important part to keep up with these relationships in dimension usage of cubes. So be sure you have the correct relationship set up in the data source view. I'm going to click OK, bring the Solutions Explorer back out, right-click our VentureWorks project, and click Deploy. Remember, you want to deploy constantly after changes just to make sure there are no errors. It's going to ask us, in this case, to overwrite the existing database, and we're going to click Yes. Once it's finished processing with no errors, then we'll be able to browse the data. We'll click the Browser tab in the cube, go ahead and pin the Deploy Progress, and we'll see in our left under Measure Groups we have Order Date, Due Date, and further down Ship Date. These are all related to the same date dimension, so if we make a change in that date dimension, it'll be reflected in the relationship because of the dimension usage. I'm going to drag the ship date calendar date out. I'm going to remove the date, and I'm going to scroll up to Internet Sales, and I'm going to drag Internet Sales to our work area. Now we can see by ship date, year, quarter, and month, and total sales for that ship. If I remove the month and I remove the quarter, we can also put out there another date like order date, and we could drag the year out there. And then it shows us in 2013 ship, there were sales in 2012 for this internet sales amount. Now you can slice and dice between different years of different dates in your fact table. The reference dimension is related to a fact table through another dimension table in the cube. This occurs when the schema was a snowflake and the dimension table was not used in the related dimension. This example shows the geography table related to fact reseller sales through the reseller dimension by geography key. The reference dimension works well when two different fact tables need the same dimension attributes that are not directly referenced through the same dimension. The geography, city, state, etc., can be added to the reseller dimension, but reseller is not related to internet sales. Internet sales has a relationship to dim geography through the customer dimension. The customer dimension is not related to the reseller sales, only fact internet sales. A dimension will have to be created from the reference dimension. In this example, geography will be a new dimension in our analysis services project. Next, the new dimension, geography, is referenced through the other dimension, reseller for reseller sales, and customer for internet sales in the dimension usage of the cube. Here is an example of the defined relationship that shows the relationship type as reference. The intermediate dimension is reseller and the attribute is geography key. This is common when multiple dimensions use the same geography table.